Hello guys, welcome back to Theta Think. My name is Dan and I'll be taking you through two separate functions here and how to differentiate it. So I have selected this function specifically for those that have issues differentiating types of functions like this. So I have here a function y equal to 1 over 1 minus x squared and all to square root or 1 out of 2. Then we have y equal to 1 over 1 minus root of x all squared. So please hit on the subscription button if you haven't and click on the notification bell for further updates if you want to have more updates from me. So let's check out the first solution. Now, when you look at this very carefully, we can use chain rule to solve this. I can represent the function in the bracket by a variable, okay? I'll differentiate that variable, blah, 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 and solve. By the end of the day, I would be forced to apply quotient rule, which I don't want to do. So I'm going to use a different method, a shortcut method that will help me to apply both the chain rule and everything in just some few steps. So before I start, I will take you through this step. Imagine I have a function y equal to 1 minus x. Okay, let's say 1 minus x all squared. Okay, if I don't want to use chain rule for this, I can use another way by saying that dy dx will be equal to, I'm applying power rule here, and watch something. So use these two to multiply the whole function. You have 2 into bracket 1 minus x, then subtract 1 from the exponent. So 2 minus 1. Multiply this by the derivative of the bracket. So when I differentiate 1, the result is 0. When I differentiate x, the result is what? Negative 1. So when I differentiate x, the result is 1. Times this one, we have negative 1. That is it. So I can just simplify the result. So I have dy dx giving me, this is 2 1 minus x to the power 1, which I don't need to write, times negative 1. So this result is equal to negative 2 1 minus x. And this is your dy dx. You get it. So all you need to do, use this to multiply, reduce the power by 1, then multiply the result by the derivative of what you have in the bracket. So that is the method I'm about to apply. You can also use chain rule to solve this. Okay, so now let's apply that method and see what we are getting. Because this is a fraction, it will involve some few steps, and I hope by the end of the day you get the concept. So we have here dy dx giving us, now use this 1 over 2 to multiply. So I have 1 out of 2, okay, times the same function, 1 over 1 minus x squared, reduce the power by 1, 1 out of 2 minus 1. Multiply this result by the derivative of the bracket. So, but I will not do that yet. So I'll write derivative. I'm differentiating the bracket with respect to what? X. So 1 over 1 minus x squared. This you are seeing here means I'm about to differentiate this side. Okay. Now, in the next step, we simplify this side. So we have our dy dx being equal to 1 out of 2. Then we have into bracket 1 over 1 minus x squared. Now when you subtract this, or when you punch this on your calculator, you have negative 1 out of what? 2 times the derivative d dx of 1 over 1 minus x squared. I'll work on this side of the function. Okay, so now let's leave this side and focus here. How do we find the derivative of this? So let's do that. So we are having dy dx giving us 1 out of 2, 1 over 1 minus x squared to negative 1 over 2 times. Now watch very carefully. I will change this to a linear function, then it will be easy for us to differentiate. I don't want to apply quotient rule here because this is a fraction. We can apply quotient rule to solve this, but I will avoid that one. So this is giving us the derivative of 1 minus x squared to negative 1. Okay, so I've changed this to a linear function. Now I'll apply the same principle I did here to solve this side. Okay, so we still have 1 out of 2, 1 over 1 minus x squared, negative 1 over 2 times. Now watch, use this to multiply. I'm about to differentiate, so use this to multiply. So we have negative 1. Write the same function, 1 minus x squared, reduce the power by 1, negative 1, negative 1. So multiply this result by the derivative of the bracket. When you differentiate 1, the result is 0. When you differentiate negative 2x, the result is minus 2x. Alright, so now this is the equation. So watch very carefully. I'll change this side, this bracket, because there is a negative here, into a fraction. So this becomes dy dx, giving us 1 out of 2, 1 over 1 minus x squared, all to negative 1 over 2 times, this is 2x multiplying. So when we change this side, we have 1 over 1 minus x squared. Don't forget there is 2 here, so we square this side. Okay, so this is it. Now these 2 can now multiply this one, so giving us 1 out of 2, 1 over 1 minus x squared, negative 1 over 2 times this time this, we have 2x all out of 1 minus x squared all squared. Okay, so now it's very simple. Now these 2 can cancel this one, and we are left with x, and dy dx will be equal to 1 over 1 minus x squared times x over 1 minus x squared all squared. Alright, so I nearly missed this. There is negative 1 over 2 here. So this is the final result, okay? 1 over 1 minus x squared, negative 1 over 2 times x over what? This. So we can leave our answer here. There's no need for you to break this down again. You see how complex this looks like. If you apply chain rule, you do like 4 pages before you get to the final answer. So this is it for question 1. Let's move on to the next question. So in question 2, applying the same principle, what do we have? So we have a dy dx giving us, now watch, 2 will multiply the function, write down the same function, 1 minus root of x, reduce the power by 1, 2 minus 1, multiply this result by the derivative of whatever you have in the bracket. So we have dx of 1 over 1 minus root x. Then let's work on this side. We have dy dx giving us 2 times 1 over 1 minus root x to power 1. We don't need to write that. Time derivative of 1 over 1 minus root of x. Now, our focus is here. So let's differentiate this side of the equation. To do this, we change this into a linear function. So watch carefully. We have dy dx giving us 2 1 minus root x times, well, let me put a square bracket here. Now this is giving me the derivative of 1 minus root of x or negative 1. I was supposed to change this, so let's change this root of x to 1 out of 2 so that we can find it easy to differentiate. Now dx of 1 minus x to power 1 over 2 negative 1. Now do you get it? So this is very simple for us to differentiate now. So we can differentiate this, and then let's work on this side. To differentiate this, we use this negative 1 to multiply the function. So we have minus 1 times the same bracket, 1 minus x, 1 out of 2. Reduce the power by 1, 1 minus 1, we have negative 2. Multiply this by the derivative of the bracket. Now watch. If you differentiate the constant, you get 0. If you differentiate this, you are getting negative 1 over 2 x to the power 1 out of 2 minus 1. Okay? So now, this is giving us negative 1 into 1 minus the the same root of x, I'm changing it back, all squared times negative 1 out of 2. When you subtract this, we are having x to the power negative 1 out of 2. Okay, so this is it. Now let's simplify what we have in this bracket. So first, I will change this to a fraction so that I can eliminate this negative. Okay, and we will use this one, this negative 1 over 2, to multiply this negative 1. Now watch. This time this is giving us 1 over 2. Then our bracket 1 minus root of x all squared. Then we multiply this by, now this is giving us 1 over x to 1 over 2. Okay, so now I have made this a fraction. Now this 1 over 2 is the same as root of x. So in our next step we can do that. So we have 1 over 2 times 1 minus root of x all squared multiplying 1 over root of x. These two can multiply this, giving us 2 over 1 minus root x, then times 1 out of 2, 1 minus root of x, or minus 2. So I think I made a mistake here. This is negative 2. This side is also negative 2. This is also negative 2. So starting from here. So times 1 over root of x. And this is it. So because of this negative 2, which I nearly forgot, we can change this part of the equation into a fraction. So I'll rewrite this one, then we do that. So we have 2 out of 1 minus root of x, still multiplying 1 out of 2, then times 1 over 1 minus root of x all squared times 1 over root x. So we can close the bracket here. All right, so now this can cancel this. We can choose to do that. So we have our dy ds giving us 1 out of 1 minus root of x times 1 over 1 minus root of x all squared times 1 over root x. Okay, so we can actually simplify this. There's no need for me to do that, but let me write the last step. So we have dy dx being equal to 1 over 1 minus root of x times 1 times this, we have 1 over root of x times 1 minus root of x all squared. So we can leave our final answer here. So I think that is it. So you can go through this very carefully to see if I've not made any mistakes, because I think I made one mistake while solving this. So thank you for joining me here. This is Dan, and subscribe to this channel if you haven't. I'll see you in the next one.